Just a quick note before we get started. This video is part of our Mathematics and Statistics module in our FE Review course. If you would like access to the complete module right now, as well as other FE Review modules, a practice exam, and live Q&As, make sure to go to the link in the description and go to our FE Exam Academy. Once you go to the link and join, you'll have access to our full support in passing your FE exam. If you find this video useful, make sure to leave a like and subscribe to the channel for future updates. That being said, let's go ahead and get into today's topic. Hello, welcome to this review of vector operations. It's all going to be on one segment covering 12 problems on various different types of vector problems. As always, make sure that you attempt these problems yourself before you follow along with the solution. But when you're ready, let's go ahead and begin. Okay, so starting off with number 1, we're given two different vectors and we need to find the addition of those vectors. They have different components. They have an I component and they have a j component. So let's go ahead and do the addition. So the way that we're going to do this vector addition is by adding the different components separately. So in this case, we need to do a plus b. So let's start off with adding the I components first. So in this case, our vector addition for the I components is going to be 2 plus 1. That's going to give us a result of 3 for the I component, plus a negative 4. So that's going to be a subtraction, and that'll give us a result of negative 1 for the j component. So then if we combine our components back together, we're going to get 3i minus j as our resultant vector. So if we take a look at the multiple choice, the answer for this one is going to be B. Moving on to number 2, we have some new vectors, and this time we need to do a subtraction instead of an addition. So let's just go ahead and do the same process we did last time. We'll go component by component. So in this case, we have an I component and then we have the j component. So let's do the subtraction for the I components first. So it's c minus d, so we'll start off with negative I there, and then we'll subtract this 4. That'll give us a result for the I components of negative 5. Then if we move on to the j components, we'll end up with 2j minus negative j. So that's going to end up being an addition, and the result is going to be 3 for the j components. So then if we put the components back together into a single vector, our result is going to be a vector negative 5i plus 3j. And if we take a look at the multiple choice, the answer for this one is going to be D. Moving on to number 3, now we have something a little different. So we are given a vector a, and we need to find 3a. So all we really need to do in this case is multiply each component by 3. And that'll give us the result. So if we start off with the I component, we're going to get 6i. And then if we go over to the j component, we're just going to get negative 3. So that is going to be our result, and our answer for this one is going to be A. Moving on to number 4, now we're given two vectors, a and b, and we need to find this combination right here with those two vectors. So it's going to be 2a plus 3b. So in order to find what that combination is, let's go ahead and find 2a and 3b first. So we'll start off with 2a. We're just going to multiply every single component in the a vector by 2, and that is going to give us 4i plus 6j minus 2k. If we follow the same procedure down here, we're going to get 3b is equal to negative 3i plus 12j. So now in order to get the result for this combination, we just need to do the vector addition of these two. So let's go ahead and do that one component at a time. So we'll start off with the I components. In this case, it's going to be these right here. So if we start off with 4 and we add a negative 3, we're just going to get 1. So I'll just write down 1i there. Moving on to the j component. If we start off with 6 and we add 12, we're going to get 18. So this one's going to be 18j. Now for the k component, we have negative 2 up here, and then this one doesn't have a k component, so it's just going to be 0 basically. So that means that this one is going to be negative 2 plus 0. That's just going to remain negative 2, and we'll have negative 2k. So this is going to be our result right here, and if we look at the multiple choice, the answer is going to be C. Moving on to number 5, now we need to find the magnitude of a vector A. So anytime that you're asked to solve for the magnitude of a vector, it's basically going to go like this. The symbol for the magnitude of a vector is basically going to look like this. It's just going to be your vector with some bars outside of it. And then what we're going to do is we're going to square each of the components, and we're going to have that all under a square root. So this is the vector that we have in our problem, and then over here on the right is just the more generalized formula of how you find that magnitude. In our case, we have I and J components, but most of the time you might see X and Y component or X, Y, and Z component. All that being said, the quickest way to find the magnitude of a vector is by using your calculator. So we basically just plug that formula into the calculator. So we'll have 3 squared plus 4 squared all under the square root, and that's going to give us a result of 5. Now if we take a look at the multiple choice, the answer is going to be B. So just like the first few problems, this one was pretty straightforward. This material is something that you should be quite familiar with from engineering school. This review is here so that you can get comfortable with these vector operations again if you haven't seen them in a while, or if you just needed a quick review. That being said, let's move on to number 6. Okay, so moving on to number 6, now we need to find the magnitude of this vector B. So this is going to look like this. So we're going to use the formula for finding the magnitude of a vector. It's going to basically look like that. We're going to once again use our calculator. We're going to have 2 squared plus 3 squared. The sign is not going to matter because when we square it, it's going to end up being positive anyways. And then we're going to have 6 squared for our third component. If we hit enter, that is going to give us a magnitude of 7. And if we take a look at the multiple choice, the answer for this one is going to be D. Moving on to number 7, now we're being asked to find the dot product of these vectors here. The formula for the dot product can be found on page 59 of the FE reference manual, as you can see here. The formula is going to be right here, as you can see. This basically tells you how you can do the dot product by hand, but for the FE exam, we are not going to be doing it by hand. We have a much better option that will save us a lot of time, and that is by using our calculator. So let me show you how to do that. Okay, so here's our calculator. What we're going to do is we're going to hit second, and then we're going to go to vector. What we need to do is we need to enter these vectors into the calculator. So the way we do that is we go to edit, and we'll start off with our first vector here. In this case, our vector is going to have 2 dimensions because it has 2 components, and our vector is going to be 2, 1 for A, okay? So now let's go back to that vector screen by hitting second and vector once again. Let's edit our second vector. In this case, it's going to also have 2 dimensions. And then we're going to have -1 and 3 for this vector. So now we can go back to this vector screen. So now that we're here, we can go over to this tab that says math on it, and we'll find the dot product operation. What we're going to do is we're going to hit the number 1, and that will tell the calculator that we're going to be doing a dot product. So then we go back to vector by hitting second first, and then this button here, and we'll put our first vector in. So we'll hit 1, and we'll put that vector there. We'll hit second and put a comma, and then we'll put our other vector in there. In this case, it's going to be this one. We'll close the parentheses and we'll hit enter, and it looks like our result is going to be 1. So the multiple choice answer for this one is going to be A. Moving on to number 8, we have another dot product problem for extra practice. In this case, we have a vector C and a vector D, and they each have 3 components. So that being said, let's go back to the calculator to find our dot product. So we can do it the same way we did last time. We'll go over here to our vector operations, start off with our first one. This time it's going to be in 3 dimensions. and it's going to be a vector with components of 5, 2, and -4. Then we go back to this main screen for vectors. We'll go to our second vector, make it 3 dimensions, and this time it's going to be 2, -1, and 2 as the components. From here, I'm going to hit second and then hit quit to go back to the main screen. Then I'll go back to the vector operations, go to the math tab, and I'll grab that dot product. Then if I go back to the vector screen, I'll grab that first vector. In this case, it's going to be this one right here. I'll grab a comma, and then I'll put our second vector in, close the parentheses, and that'll give me a result, and the result is going to be 0. Therefore, the answer is going to be C. Moving on to number 9, now we have a problem where we need to find the cross product of these vectors A and B. So if we go to the FE reference manual, we're also going to find a formula for the cross product here. As you can see, you can do it by hand by filling out this little diagram, but we can also use our calculator for the cross product, and it's a lot faster. So let me show you how to do that. Here we are back at our calculator. So let's go ahead and go back to that vector screen and edit our new vectors. So in this case, our vectors have 3 dimensions. This first vector A is going to have components 1, 2, and 3. Now let's go ahead and edit our second vector. It's going to have 3 dimensions as well, and it's going to be 4, -1, 2 for the components. So then we can hit second and hit quit. And when we go back to our vector screen, we can grab the cross product this time instead of the dot product. Now let's grab our vectors. There's our first one. We can then hit a comma and put our second one. And that is going to give us our result once we close the parentheses and hit enter. So our result is going to be a vector with components 7, 10, and -9. So if we take a look at the multiple choice, it looks like our answer is going to be B. Moving on to number 10, we have one more practice problem for cross products. This time we're given vectors C and D. So let's go ahead and use the calculator to get our solution. So we'll go once again to our vector screen. We can edit that first vector. It's going to have 3 dimensions. It's going to be 2, 1, and 1 for the components. Then we can go back to our vector editor, and for our second vector, it's also going to be 3 dimensions, and it's going to be 1, -3, and 4 for the components. So then if we hit second and hit quit, it'll take us back to the main screen. We go back to our vectors, go back to math tab, we'll grab the cross product there, and then we just enter in our vectors, close the parentheses, and hit enter. So now our solution is going to be a vector with components 7, -7, -7. So if we take a look at the multiple choice, the answer is going to be A. So now moving on to number 11, we have something a little different. We need to find the angle between these vectors A and B. So the way that we're going to find the angle between two vectors is by using this formula right here. We're going to ignore this in the middle. This part in the middle is not important because it's just the definition of a dot product. What we really care about is that the dot product is going to be equal to the magnitude of the two vectors multiplied together times cosine of theta. So obviously the angle between the two vectors is going to be that theta there, and that's what we want to find. So let's go back to our problem. So now let's go back to our problem, and I'll go ahead and write out that formula for us here. It was basically the dot product is equal to the product of the magnitude of the vectors times cosine of theta. So taking a look at this formula, we can see it's basically going to combine a little bit of everything we've been doing so far. We need to find the dot product for our vectors and the magnitudes. So let's go ahead and use the calculator to do that. So here's our calculator. Let's go ahead and start off by finding the dot product. So let's go ahead and edit our vectors. In this case, we have a vector in 2 dimensions for this first one. and it's going to have components 1 and 1 for vector A. Then let's put in our next vector, which is B. This one's going to also have 2 dimensions, and it's going to be 1 and -1 for the components. And then I'll go back to the main screen and I'll grab the dot product from this math tab in the vector section. And then we just grab our vectors and we make sure that there's a comma in between, as you can see here. And then when I close the parentheses and hit enter, it's going to tell me that the dot product of A and B is 0. So I'll go ahead and put a 0 right here. And now we need to find the magnitude of A and the magnitude of B. So let me go back to the calculator here and start off by finding the magnitude of A. The components are going to be 1 and 1, so it's going to be the square root of 1 squared plus 1 squared, and that is going to be square root of 2. If we hit this button right here, it's going to convert it to a number, so we can go ahead and grab that number. We'll just round it to 1.41. Then we need to find the magnitude of vector B. As you can see though, these have the same components. They both have 1 and 1 for the I and j components respectively. So therefore we can know that the magnitude of A and B is the same. So it's just going to be 1.41 once again. So once we put all of those into our formula, we're going to end up with this. So now we can go back to the calculator and we can actually have it solve this equation for us. We'll go to second, and then we'll go to number solve right here, and then we'll just fill out our formula. So we have 0 on the left side, we have 1.41 times 1.41 on the right side, and then we have all of that multiplied by cosine of theta. In this case it'll just be x as a placeholder for us. So then we can hit enter and it's going to solve, and as you can see it's going to give us that x equals 90 degrees. So in our case, instead of x, we have theta. It's the same thing, it's just our variable. So for us, the answer is going to be 90 degrees, and that means that from the multiple choice, it's going to be D. So moving on to our last problem, number 12, we have one more practice problem on finding the angle between two vectors, this time vector C and D. So we're going to follow the same procedure that we did in the previous problem. So this is going to be the formula right here. It's just going to be C and D instead of A and B because the vectors are just named different. If you need a reminder on this formula, just go back to the last problem or look at the FE reference manual. So let's go back to our calculator to find our dot product as our first step. So let's go ahead and go to our vector section. We'll go edit our vectors. We'll start off with our first one. It's going to have 2 dimensions. And the components are going to be 2 and 2. So then we'll go back and edit our second vector. The components for this one, which is also a 2-dimension vector, are going to be 3 and -1. So then I'll hit second, I'll hit quit, I'll go back to our vectors tab, and I'll grab the dot product again. And we'll put our vectors with a comma in between, as you can see right here. Now let me just close the parentheses and hit enter, and it looks like the dot product of those vectors is going to be 4. So I went ahead and put 4 here in order to start filling out our formula. So now we need to find the magnitude of C and the magnitude of D. So let me show you actually a faster way of doing it than last time. In this case, we can go to our vector section again in our calculator. When we go to the math tab, we can grab this norm magnitude tool. This is going to be the third one. So we'll just put it there, and then we'll start off with our first vector, and it's going to give us a magnitude of 2 square root of 2. If we hit this button right here, it's going to give us this number, which is the equivalent of 2 square root of 2. So it looks like we can round it to 2.83. So I'm going to go ahead and put that right there. Now let's do the same thing for our second vector. Let's go and find that magnitude, and then we'll just find our vector one more time. So it's going to be our second vector in this case. We'll close the parentheses and hit enter. Now we're given square root of 10, we can hit this button once again, and it tells us that it's going to be 3.16 if we round it. So we're going to end up with this right here. So once we fill out our entire formula, we're going to end up with this right here. So now we can go back to our calculator one more time and use that solver. So this time we have 4 on the left side, and then let's put in our new equation. It's going to be 2.83 times 3.16 times cosine of x. That's going to be our formula, as you can see here. We're going to hit answer and have it solve for us. And it looks like the answer is x equals 63.43. We can just round it to 63. So it looks like our theta is going to be 63 degrees. That means that the answer for us is going to be C in the multiple choice. So that last problem brings us to the end of our review on vector operations. I hope that it was very helpful, and as always, if you have any questions, make sure to send me a message. The next section is going to be some problems on statistics. It's going to be a lot more problems in this one because we have a lot of stuff to get into. But when you're ready, we'll see you there.